Welcome back. In this video, we will try to understand the context package. Before we get into the context package, let's try to understand the client request scenario. Let's say client sends a request to the server and server is running application in Go language. So incoming client request has its own handler and each handler has own Go routine or a thread. Now the request handler often starts the additional Go routine to handle to fulfill the client request. Example like it sends request to the database or the remote procedure call to the some other server. The set of Go routines working on a request typically needs to access the specific value such as the identity of a end user or authentication or a token or the request deadline. What if a request got cancelled by the user for some other reason or request got timeout? How our application should handle this scenario? We can cancel all the Go routines or the operation getting performed or requested by the end user. So this is where context package helps you to reclaim all the resources they are your application or the set of request using. We need a way to propagate the cancellation message into the request scope and call graph across all the Go routines. Context package serves two primary purposes. One is it provides the API for cancelling the branches of call graph, and second is it provides a baggage that helps to transport a request scope data throughout the call graph. Here is an example which shows how the context propagates throughout the life cycle. Example like main Go routine creates the root context and it derives the cancellation context from the root context and passes to the function 1 and function 2. Function 1 derives the new context from the cancelable context and sets the timeout for 1 second, let's say. And function 3 is supposed to complete its execution within a 1 second. Otherwise, it will time out and return context back to the primary. And function 2 is not affected from this timeout because we pass the context that is in the form of pass by value. This allows the compatibility of the application and the individual call graph can have its own properties without affecting the context of the parent graph. The core of context is the context type. Now let's talk about the context interface. It has 4 different methods which are done, error, deadline and value. Done method returns a channel that is closed when context is being cancelled or timeout. Error method returns the error, indicates why the context was cancelled. Deadline can be used to check if the context will be cancelled after a certain time, and the value is the value method returns the value with a key in a context or nil. Context can be accessed simultaneously by more than one Go routine. We can pass the single context to any number of Go routine and cancel the context to send signal to all the Go routines to abandon their work and terminate. Now let's look into the function that are provided by the context package to create the new context, that is context.background and context.todo. Context.background is the main is used to create the parent background context, and that is used by the main function. Background function returns the empty context. It is the root of all the contexts or the context tree. It is never cancelled and has no value and no deadline. It is typically used by the main function and it acts as a top level context for the incoming request. Now let's talk about the to-do function. To-do function returns the empty context. but the intended purpose is to serve as a placeholder. It is used when we do not know which context to utilize, or if we expect our code to perform within the context, but the upstream code has not yet furnished one. Then we use to do context as a placeholder.